Well, this one is just matching, right? So if I want to figure out what the expression h is, I can see that that would be the distance from a to a plus h is going to be h. Wow, I didn't do that very well. That's this distance here, right? And so that's the same as distance e. So the answer there is e. Okay, for f of a, that just means I take a and plug it into my function. And so that would be the y value of the function. So that's a. F of a plus h. It's going to be start here at a plus h. And we want to plug that into the function. And the y value that we get there is b. And for a plus h minus f of a plus h minus f of a, that's going to be the distance between these two. So this is f of a. This is f of a plus h. So f of a plus h minus f of a is going to be this distance here. So that gets me f. And then f of a plus h minus f of a over h, this is the slope of that secant line. So if I look at this line through these 2 points, that's this line, and the slope of that is labeled d. And then again, the slope, this thing is the derivative, so that's the same thing as f prime of a. That's the slope of the tangent line. And so the tangent line is this line here, and the slope of that is labeled c. So for this one, I have a continuous function, so that's an important piece of information. It has the following known values. So this maybe isn't necessary, but might be something that's good to kind of think through. Let's see if we can just plot these points, and then we can kind of think, okay, we need some continuous function that connects them. So when x is -3, my function value is -2. When x is -2, my function value is 3.5. So put that there about. When x is -1, my function value is 6, so it goes up from there. Okay, and then when f is 0, my function value is 1. And when x is 1, my function value is -0.5, so there. When x is 2, my function value is -2. And when x is 3, my function value is -4. So that just can kind of help you visualize what the function might be doing. So those are just points in our function. We just know it's continuous in between those points somehow. So the question is, does f of x equal to 4.2 have a solution? So in other words, I'm looking for a place where my function value is equal to 4.2. So that would be here. Well, so I can see that I have some function values that are below 4.2 and some that are above 4.2. And so since this is a continuous function, then the intermediate value theorem says that it's going to have to go through, it's going to attain every y value in between those two y values. So at some point it's going to hit. So the answer is yes. So we can say since f of -2 is equal to 3.5 and f of -1 is equal to 6, and 3.5 is less than or equal to 4.2 is less than or equal to 6. So so there is a C between those two x values, -2 and -1, such that f of c is equal to 4.2. So the c would be a value somewhere here, and that's where it goes through that line at 4.2. Okay. So the next question is the minimum number of zeros that the function must have. So when I'm looking for zeros, I want to look for, again, places where it has to cross this x-axis. And so I can look here and I can see that from x equal -3 to x equal -2, I have this jump from a negative value to a positive value. And again, I have another jump like that from x equals 0 to x equal 1. I have another jump there. So in other words, we're really looking for those places where the y values go from negative to positive or positive to negative. So I would say the minimum number, it definitely has 2 zeros. It could have more because, you know, like I know that these two values are on my graph, but it could do like something like that in between, you know, we don't know. But anyhow, definitely it goes through somewhere between these points and these points here. So we have 2 by the IVT. So there must be a 0 on the intervals -3, 2 and 0, 1. So we have 2 intervals where we definitely are going to have a 0. Use the table of values to approximate f prime of 2. So, so to approximate f prime of 2, so there are really 3 reasonable ways to do this. So, and all of them involve finding an average rate of change. So one thing I could do is I could do the average rate of change between x equal 2 and x equal 3. Another thing I could do is find an average rate of change between x equal 1 and x equal 2. And then the other thing I could do is I could take those two values and average them, which is the same thing as finding the average rate of change from x equal 1 to x equal 3. So let's just write all of those down. So any of those 3 could be a reasonable response. So I can find so if we use the interval 2 to 3, then we'll have f of 3 minus f of 2 over 3 minus 2. Gives me -4 minus -2 over 3 minus 2, so that gives me -2. If I use the interval 1 to 2, that's going to be f of 2 minus f of 1 over 2 minus 1, and so that gives me -2 minus -0.5 over 2 minus 1. So I get -1.5. And then I could also use the interval 1 to 3, which is the same thing as averaging those two. So I could do f of 3 minus f of 1 over 3 minus 1. And that would give me -4 minus -0.5 over 3 minus 1, which gives me -1.75. So any of those 3 is a reasonable answer. So this one is kind of, kind of going to the right, this one's kind of going to the left, and this is kind of straddling the two or averaging the two. So any of those is a reasonable approximation for f prime of 2.